Class 9 IIT Mathematics. Let's revise two chapters on today. Okay, let's go for trigonometry. So basic trigonometric concepts. Generally, I will write on the board. First one, trigonometric ratios.
Yes.
So we have 6 trigonometric ratios. Shortcuts we will write. Sin theta, cos theta, tan theta are the basic ratios. The reciprocals, cosec theta, sec theta, and cot theta. But read as cosecant theta, secant theta, cot theta. These are the reciprocals. Now, the definition of sin theta. Length of side opposite to the angle and the length of hypotenuse, the ratio in between. So to define the ratios, we need a right angle triangle here. So based on right angle triangle, we will define this. Right. This is A, this is B, this is C. So longest side we call it as hypotenuse, and this is acute angle. AB is the opposite side, BC is the adjacent side. So longest side. Now sin theta first I will write. Sin theta is defined as the ratio of opposite side and hypotenuse. One opposite side, for which opposite side? Opposite to the acute angle, this theta. Theta, we are defining sine according to the theta, according to this angle. So I'm dividing according to that angle. That means sine C that is defining according to sine C. Suppose if I define, then it will come as AB by AC. If I define according to sine A, then this will be the opposite, this will be the adjacent, and hypotenuse is same.
Yes.
Opposite and hypotenuse. Hypotenuse won't change. You will get BC by AC, like this one. So you should have the clarification on this. Based on theta. Here theta I took C. Sometimes you will take here. Next cos theta. Cos theta in the sense cos C. Adjacent. The ratio of adjacent and hypotenuse. The ratio of adjacent and hypotenuse. Adjacent is BC. Hypotenuse is AC. Next tan. The ratio of opposite and adjacent. Opposite is AB and adjacent is BC. Then reciprocals. Cosecant theta, reciprocal is sin theta, hypotenuse by opposite. That means AC by AB. Secant theta is a reciprocal of cos theta. That is hypotenuse by adjacent. AC by BC. And then cot theta is the reciprocal of tan theta. BC by AB. BC is adjacent and opposite. Adjacent is BC, this is AB. This is the first concept, trigonometric ratios. First concept what we learn in trigonometry. Okay, trigonometric ratios definitions. And the second concept in trigonometric ratios is trigonometric ratios of some specific angles. We define some specific angles. Specific angles. Trigonometric ratios of specific angles, right? So already I told you how to remember. Just to take first 5 whole numbers and divide them with 4. And then take the square root, 3 steps. So here you will get 0. Here you will get 1/2. Here you will get 1. So root 0, root 1 by root 4, root 1 by root 2, root 3 by root 4, root 1. 0, 1/2, 1 by root 2, root 3 by 2, 1. So these are the values. These 5 values we get from these 3 steps. Then how to remember now? 0, 1/2, 1 by root 2, root 3 by 2, 1. What are these? These are sine angles. Sine, what angles these are? These are sine 0 degrees, sine 30 degrees, sine 45 degrees, sine 60 degrees, sine 90 degrees. Then cos theta, write in reverse way. So 1 to 0, we will write 1 to 0. It's like this. First 1, next to root 3 by 2, 1 by root 2, 1/2, 0. This is cos. Then tan. Sine and cos division you do. Sine divided by cos. 0 by 1 is 0. 1/2 by root 3 by 2 is 1 by root 3. 1 by root 2 by 1 by root 2 is 1. Root 3 by 2 by 1 by 2 is root 3. 1 by 0 is not defined. So basic angles we got. Sine, cos, tan. So I'll write again. Neatly. 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Sine values. 0 is 0, 1/2, 1 by root 2, root 3 by 2, 1. Now I did not use any concept directly around because I can remember. Suppose if you get confusion, you have to use that logic 0, 1, 2, 3, 4, 0, 1, 1, 2, 3, 4 numbers you write and then divided by 4 and then square root. You don't get any confusion. This is the hint. Next, cos values, write in the reverse way. 1, root 3 by 2, 1 by root 2, 1/2, and 0. Tan divided. 0 by 1 is 0, 1/2 divided by root 3 by 2, 1 by root 3. This is 1, this is root 3, this is infinity. Now we know how to write the reciprocal angles. Sine reciprocal is cosecant. Cosecant reciprocal means 0 reciprocal infinity, 1/2 reciprocal 2, 1 by root 2 root 2, 2 by root 3, 1 reciprocal 1. Secant theta is a reciprocal of cos theta. 1 reciprocal 1, root 3 by 2 reciprocal 2 by root 3, 1 by root 2 reciprocal root 2, 2, 0 reciprocal infinity, undefined.
Okay, sir.
Last one, cot theta is the reciprocal of tan. 0 reciprocal is infinity. 1 by root 3 is root 3. 1 reciprocal is 1. Root 3 reciprocal 1 by root 3. Infinity reciprocal 0. So this one we got 1 by 0. This is 0 by 1. So this is the second concept in trigonometry. Trigonometry ratios of specific angles. Okay, no?
Yes, sir.
Now, third concept. What is the third concept? Third concept, complementary angles. trigonometric ratios of complementary angles. What is this complementary angle? So we'll take a right angle triangle. A, B, C. As usual, this is the hypotenuse. Theta I will take. This is opposite. This is adjacent. So I'm defining here sine theta. This is very logical. Okay. Theta is very much important here.
Yes, sir.
Secant theta and cot theta. Sine theta value opposite. I'll just write shortcuts. Opposite I'll write as O by hypotenuse, adjacent by hypotenuse, opposite by adjacent, hypotenuse by opposite, hypotenuse by adjacent, and adjacent by opposite. These values AB by AC, BC by AC, AB by BC, and AC by AB, AC by BC, BC by AB. Now, this is in this right angle triangle occurs, one angle is the 90 degrees, angle B is equal to 90.
Yes, sir.
Then this I'm taking as 30 degrees occurs. Then what will be this angle?
60 degrees, sir.
60 degrees. How did you get 90 minus 30 only?
30, yes, sir.
Suppose it is x. You will write 90 minus x, no?
Yes, sir.
Suppose it is theta. What you will write here?
90 minus theta.
90 minus theta. Complementary in the sense sum of angles 90, no?
Yes, sir.
Right. So that here I will define complementary angle is A, no. For angle C, complementary angle is A. Because their total is
90 degrees.
So I will write here 90 minus theta. So our task, you have to define these values now. I'll write it will close. Sine 90 minus theta. Next, tan 90 minus theta. Secant. Right. So before I already explained you, these all are sine C. Yes, no? These are C's. And these all are A's. Yes. So according to A, opposite and adjacent will be changed. Am I right?
Yes, sir.
So according to A, opposite will be BC and adjacent will be AB. And hypotenuse is same. See?
Yes,
Are you observing? According to A, adjacent is AB, hypotenuse is AC. And opposite is BC, adjacent is AB. And cosecant reciprocals I'm writing. So why do I define all this? If you observe carefully, we do matching now. Match the following. This are AB by AC. AB by AC, where it is? See, I'm writing. Yes, no? Next, BC by AC. This one. Next, AB by BC. Where is AB by BC? Cot.
Got it, sir.
Next, next you check. Next one. AC by AB. Secant. Next to AC by BC. The secant. This is cot. So why do we do this matchings and all? I will clarify. So here I will write on the right side. Okay. So sine theta is equal to, you got cos 90 minus theta. Am I right?
Yes, sir.
And reverse, I will write reverse. Sine 90 minus theta is equal to cos theta. You just check the matching. Am I writing correct or not? You check. Cos 90 minus theta, you got sine theta. And tan 90 minus theta, you got cot theta. And cosecant 90 minus theta, you got secant theta. And
Yes, sir.
secant 90 minus theta, you got cosecant theta. And
Yes, sir.
cot 90 minus theta, we get tan theta. This is the result. Okay. These are the complementary angles. Sum of two angles is equal to 90. Sin 90 minus theta, cos theta is equal to 90 degrees. Cos 90 minus theta and sin theta is equal to 90 degrees. So this result we have to remember. Okay. This is the third concept. Understood?
Yes, sir.
You take screenshot. This will be not in your textbook. Okay. The next trigonometric concept is the fourth one. Fourth one, let's see. Fourth one is trigonometric identities. The four concepts only. Identities. Trigonometric identities. So what are these? So we have three trigonometric identities. Sine square theta plus cos square theta is equal to 1. Next, secant square theta minus tan square theta is equal to 1. Next, cosecant square theta minus cot square theta is equal to 1. These three results. But how do we get? Briefly, I will explain. So this is also depends upon right angle triangle concept. Let's take right angle triangle. Is equal to 90. And right angle triangle concept is AC square is equal to AB square plus BC square. Okay. First you divide with AC square. First identity. Whole equation divide with AC square. So right, this will be 1. 1 is equal to AB by AC whole square. BC by AC whole square. AB is what? Opposite only, no?
Yes,
AC is hypotenuse. Opposite and hypotenuse is sine theta. And BC is adjacent. Adjacent and hypotenuse cos theta. In trigonometry, sine theta whole square, we will write sine square theta. We should not write sine theta square. This is wrong.
yes, sir.
So the first result, sine square theta plus cos square theta is equal to 1. So the second result here I am doing. Same identity you take, AC square is equal to AB square.
So we should take the theta at C only, sir.
C also you can take, anything you can take. A also you will get. If you take A, BC by AC will come. That time also
Yes,
sine only will come.
Yes,
Now
sir.
divide with AB square. Divide with AB square. AC square by AB square. AB square by AB square. BC square by AB square. This is 1. AC by AB. 1. BC by AB. AC by AB value how much? AC
Sir?
by hypotenuse by opposite. Hypotenuse by opposite. What is that answer? AC by AB.
Perfect. Consequence, sir.
Yeah, very good. Cosecant square theta is equal to 1 plus adjacent by hypotenuse secant square theta.
Yes,
So if you bring this side, you will get cosecant square theta minus secant square theta is equal to 1. We get third identity here. The last one, if you divide with BC square, you will get automatically the last one. Let's divide with BC
Then
square.
here cosecant square theta minus secant square theta is 1. That is second identity, sir.
Cosecant square, this wait 1 second. Cosecant square theta minus cot. This is adjacent, no? Cot, no, very good. Cot. Cosecant square theta minus cot. Oh, this is not second, this is a third. We got third identity first.
Okay.
Now second we will get. Okay, second we will get. You please try on this one. Divide with BC square. How much did you get?
Yes, sir.
AC by BC. AC by BC. Hypotenuse by adjacent. Hypotenuse by adjacent is secant square.
Yes, sir.
Akansh.
Sir.
So you have to get secant square minus tan square. This AC
Yes,
by
sir.
BC is a secant is equal to, this is tan plus 1. So just bring out left side, secant square minus tan square is equal to 1. These are the identities. These are the 4 important concepts in trigonometry. So whichever question comes based on these 4 concepts only we will get. And there are some next level problems are there. We will get time, we will do. But these are the basic concepts. Okay. Next we go for polynomials, right?
Yes, sir.
See the polynomials. Polynomial is an algebraic expression contains a variable which is having non-negative integral powers. Non-negative integral powers. That means the exponent of the variable should not the negative power. I will write here 5x cube plus 3y square minus 2y. This is one example. 6x cube plus 5 by 2x and 3 root x plus 3 by x. So I wrote some examples here. So non-negative integral power, non-negative. So in number line -1, 0, 1, like this will be. Non-negative in the sense, from here we shall take 0 onwards. Okay, or whole number also we can make. Right, whole number. The exponent should be a whole number. So just check here power 3, power 2, power 1, variable powers 3, 2, 1. It is a polynomial. Here 2, and this is denominator, and this is root, and this is in the denominator. If any power is in the denominator, if I bring to the numerator, it will come x power -1, and this will become as a fraction, and this will become like this. We don't want fraction, we want only whole number. Okay, so the polynomial
root also we don't consider, sir.
Yeah, root also we don't want. Root in the sense that is a fraction, no?
Yes, sir.
So based on the number of terms, we have defined some types of polynomials. Based on the degrees, we have defined some types of polynomials. So based on number of terms, monomial, binomial, trinomial, multinomial. Monomial, binomial, trinomial, multinomial. The number of powers. See here, I will tell you an example. Root 7x, 7 root x, which is a polynomial. Root 7x, 7 root x, which is the polynomial. Confused? Akansh.
Sir?
Root 7x, 7 root x, which is the polynomial.
Root 7x, sir.
Why so? You are not telling the answer confidently. Why it is polynomial? Okay, this is not a polynomial, already I said. Root is there. How can you say this is a polynomial? Yes, you are correct, because just check only the variable. You don't worry about the constant. Variable. What is the variable power? Yes, 1. Is a polynomial. Okay. Root 7 is also polynomial, because if I take x, I can write power 0. Okay.
Yes, sir. Yes, sir.
So now based on
we don't consider the we only consider the variables, sir.
Yeah, variable power only you have to see. You don't worry about the constant.
Okay.
So first, just now I wrote root 7, root 3 minus 2 by 5. And second I will write just number 0 I will write. And then third I will write 2x plus 5, 3x minus 5. And then I will write 4x square minus 3x plus 2, 7x square minus 5. So here different polynomials I wrote, and I will name it now. First one I will name as constant polynomial. Second one I will name as zero polynomial. And third one I will name as linear polynomial. This is quadratic polynomial. Then it is cubic polynomial. Okay, so different types of polynomials, quadratic polynomial, cubic polynomial. We can define power 4 also by quadratic polynomial. This is by quadratic polynomial. By quadratic polynomial, and some other polynomials also, there prime polynomial, primitive polynomial, irreducible polynomial. Those are not necessary. So till by quadratic polynomial is enough for us. Now why do we define them? So here constant polynomial, there is no degree. I can take it as x power 0. X power 0. The polynomial which is the degree 0, that is constant. And here nothing is there, 0 is there. So 0 polynomial, I can't define the degree. 0 polynomial degree we cannot define. Okay.
Yes,
So the degree of the 0 polynomial is undefined. And linear polynomial degree is 1. And quadratic polynomial degree is 2.
yes, sir.
Cubic polynomial degree is 3. Biquadratic degree is 4. So based on this, these are the basic concepts: constant and 0 polynomial, linear polynomial, quadratic polynomial, cubic polynomial, and biquadratic polynomial.
Yes.
Then next, a part of this, what are there in polynomial? Finding the 0 of the polynomial, root of the polynomial. Okay. Next, factorization. Next, some formulas we have defined: a plus b whole square equal a square minus b square, x plus a into x plus b, a cube plus b cube, a cube minus b cube, a cube plus b cube plus c cube minus 3abc, a plus b whole cube, a minus b whole cube, a plus b plus c is equal to 0, a plus b plus c whole square. You have the formulas, right? In page number 58, you can check. So based on these formulas, we do the factorization. Factorization these formulas only. And also the zeros of the polynomials, right? These are you can define degrees and zeros of the polynomial, right? Once you can go from page 58, 59. Those are like factorization through the identities. Once you check number 58 onwards, just see that.
Yes, sir. Yes, sir. There are.
Okay. Next, we shall go for linear equations in two variables. Linear equations in two variables. Okay.
Yes, sir.
So what is this linear equations in two variables? First of all, what is meant by a linear equation? So I will write a equation here: 2x plus 5. 2x plus 5y. First one is linear equation in one variable. Second one is linear equation in two variables. That means the degree of the variable is 1 here. The same here also depend upon the degree. We just now define linear polynomial, no?
Yes, sir.
Linear polynomial, no? Yes, that is linear equation in one variable. Now linear polynomial in the sense, if we get y, linear equation in two variables. That's it. So what we do with these linear equations, generally we have solutions, how to solve. Elimination method, methods of solving linear equations in two variables. Some methods we have done, no? Substitution method. Next, reducing into linear equation form, right? Different sums we done. One sum we will do. What is this? Reducing into linear equation form. We'll see now. Let the question here: solve 8 by x minus 5 by y is equal to 24. Next, 34, not 24. 3 by x minus 2 by y is equal to 13. We take these two equations. So if you see carefully, by x by y is common in both of them. So I will separate that 1 by x, 1 by y. Here 1 by x, 1 by y. So this is, let you take 1 by x is a, 1 by y is b.
Yes.
1 by x is a, 1 by y is b. Now this you will write 8a minus 5b is equal to 34. Now this is x. 3a minus 2b is equal to 13. Now we have to solve these equations. Substitution method, elimination method, anything we can take. I will take substitution method. 3a is equal to 13 plus 2b. A is equal to 13 plus 2b by 3. So this a value I will substitute here. Okay. 8 into 13 plus 2b by 3 minus 5b is equal to 34. But if I solve this, I will get b value. So 8 13s, just to multiply more. 8 13s multiply and tell me.
Yes.
8 13s are how much?
104.
104. 8 2s are 16 by 3 minus 5 is equal to 34. Take 3 as LCM. 104 plus 16b, 5 3s are 15b is equal to 34. This transpose 104, 16 minus 15, 1b, 34, 3 is 102. B is equal to 102 minus 104, you will get minus 2. B value we got. B value substitute here. A value will get 13 plus 2 into minus 2 by 3. 13 minus 4 by 3, 9 by 3, you will get 3. So A value is 3, B value is minus 2. But A value is 1 by x. 1 by x is equal to 3. X is equal to 1 by 3. And B value is 1 by y. 1 by y is equal to minus 2. Y is equal to minus 2. Okay. This method is called reducing the linear equation. Reducing into the linear equation form. Then after I told you like system of linear equations of some conditions. A1 by A2 not equal to B1 by B2. A1 by A2 is equal to B1 by B2. Single solution, many solutions, unlimited number of solutions. Do you remember? No.
Yes.
Once you check out single solution in the sense, 3 types of equations we have defined over there. So this is the single solution intersecting lines. These are no solutions which are parallel lines. This line always we represent with arrow. And coincide a line overlap another line. These are intersecting lines. These are
Yes, sir.
parallel lines. Coincident lines. So
Yes.
here one solution, here no solution, here many solutions. There are 3 types. Okay, no? Yeah, just you go through all these points. And Friday
Yes,
one
sir.
more class we have, right? No.
Yes, sir.
No.
Sir?
Friday one more class we have, no?
Yes, sir, we have.